So in this video, we're going to go through what we would normally do in class as guided notes. So we're going to do the warm-up, the examples, and I need you to be following along on your note sheets as I am. Alright, so to start we have the warm-up. The first question is negative 3x equals 12. So I'm going to have you try to do this both ways, like we've been doing in class. So negative 3x equals 12. X, I write what's happening to the x, that gives me 12, and then I'm going to work backwards. Okay, so take a second to do that, and then I'm also going to have you do that the other way, best you can, trying to write it with the balancing equations method, more like you did in 6th grade. Okay, alright, so for the method on the left, the flowchart, we're thinking we have x. What is happening to the x? Well, it's getting multiplied by negative 3. Okay, so I have x times negative 3, and that's what gives me 12. So then my question is, how do I undo multiplying by negative 3? And I undo multiply negative 3 by using the inverse of multiplying, which is dividing. So I divide by negative 3. And then we do 12 divided by negative 3. That's going to give me x equals negative 4. Because a positive divided by a negative is a negative. Alright, so that's the correct answer. Let's look how we could have done it the other way. The other way involves the same process, we're just going to write it out a little differently. I have negative 3 times x, and I'm asking myself, how do I undo multiplying by negative 3? Well, I undo, like we did, right here. The way to undo multiplying by negative 3 is divide by negative 3. So on this side, I'm going to divide by negative 3. On this side, I'm going to divide by negative 3. You could write the division sign if you wanted, but remember that the fraction bar is the same thing as division. Okay, so negative 3x divided by negative 3 is 1x, or just x. And then 12 divided by negative 3 is negative 4, like we just found. So that is the correct answer to the warm-up. Alright, I'm going to have you do now the exact same thing for question number 2. I have q minus 4 equals 17. Q minus 4 equals 17. I want you to solve it both ways. Alright, so I have q, and what am I doing to q? Well, right now, q is being subtracted by 4, and that gives me 17. So now I need to undo that in order to solve for q. I'm going to ask myself, well, how do I undo subtracting 4? And it is adding 4. That's by using the inverse. So I am going to add 4 to my 17. 17 plus 4 is 21. So q equals 21 is the correct answer. Okay, and I could write it out that way with the flowchart, or I could write it out this way. Again, same process. Q minus 4 equals 17. So I'm going to ask myself, how do I undo subtracting 4? I undo subtracting 4 by adding 4. So I'll write q minus 4, rewriting that part, and then adding plus 4. Now on the other side, I have 17, and I'm adding 4. I know that's a part that's a little bit confusing to people. So the idea is I rewrite what I have, and then I add 4 to both sides. Right, so this part didn't change, q minus 4, that's the same, and 17 didn't change. Keep that the same, but then I add 4 to both sides. Alright, so then I'm going to say minus 4, this is like plus a negative. Negative 4 plus 4 is 0. So I get q plus 0 equals 21. And we know 0 plus anything is what we started with, so q equals 21 is our answer. Alright, so that's solving one-step equations. What we're going to do today is looking at writing two-step equations. So to write two-step equations, we're not going to solve them this week. That's what we're doing next week. We just want to work through setting it up. So, read along with me. Example 1, write a two-step equation to represent a situation. What equation can be used to represent the number of golf balls in Marley's and Tucker's collection? So we have Marley's collection here. They don't tell us much about that. But then they give us a lot about Tucker's collection. So Tucker has in total 159 golf balls. And we're told that Tucker has 3 more than twice Marley's collection. Alright, so let's try to break that down. So that's what I've done here. Tucker has 3 more golf balls than twice the number of golf balls that Marley has. In total, Tucker has 159 golf balls. Alright, so this picture is pretty nice with explaining that. Both the ways we're describing how many golf balls Tucker has. Tucker has 159 golf balls, and then if we compare the number of golf balls to Marley's collection, we know he has 3 more golf balls, then twice M. We're going to say M is the number of golf balls in Marley's collection. So now I'm going to try to write that in equation form. I'm going to start in like a word form and then we'll go from there. Okay, so Tucker's the total number, I'm going to start there, the total number in Tucker's collection, that's going to be equal to 3 more than twice Marley's collection. Or like the number of golf balls that Marley has. Alright, then let's fill in the missing parts. So what's the total number in Tucker's collection? 159. It's the total number that Tucker has. Alright, so 3 more than, we're really just going to put a 3 there. The more than is signaling addition. So it's going to be 3 more than twice Marley's collection. Alright, so Marley's collection we're going to call M. And then twice M is 2 M's, right? 2 times M. We have M plus M or 2 times M. So twice Marley's collection. So that's going to be the equation. 2M plus 3 equals 159. This represents the situation above. It represents the number of golf balls in Marley's and Tucker's collection. And next week we're going to learn how to solve that. Alright, so at this point I'm going to have you give the Triad a shot. So here's the situation, read it along with me. Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments P. What equation represents the relationship between the cost of the laptop and Cole's payments? Alright, so this diagram is going to help us. That can help us set it up a little bit. So the cost of the laptop, that's the total cost of the laptop, is $335. And then he makes a down payment, so a down payment is something you pay one time when you're buying something, of $50. And then he pays the rest in 6 equal monthly payments, which we're going to call P. So there's 6 P's there, 6 monthly payments. We want to write an equation that represents the relationship between them. Alright, so I'm going to give you a minute to try that. What I would recommend is go back to the example that we just did. Right, we had 159 golf balls. That's what our equation was equal to. And then this bottom is going to be what's on the other side, where we had 2 M's plus a 3. Right, so that's a very similar situation to what we have here. Alright, give that a try. Alright, so the correct equation is 6P, 6 times P, plus 50 equals $335. So let's break that down. $335, that's the total. Right, so that's going to go on one side of the equal sign. That's my total. That's what I see here. And then below it is equal to that. It's how I'm going to pay for it. So I have $50. That's my down payment. And then I have 6 equal payments of P. So 6 times P. I could also write this out as like 50 plus P plus P plus P plus P plus P plus P equals 335. That would also be true, right? This is just a nicer way to write that because we have p added to itself 6 times, right? Then that's multiplication 6 times p. All right, awesome. Okay, so then we're going to look at example 3. I mean, it's our example 2, it's example 3 from the book. Which is when we're going to try to interpret these expressions, these equations, to figure out which one is correct. So read along with me. Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? All right, so these are my 3 options. In option number 1, 2 and 3, I have equals 104. That's great, because that's the total cost. And total is always going to be on like one side of the equal sign, right? That's the total cost. So we're good there. That's what should be the case. We have to figure out what's going on the left side. All right, so if Claire bought 8 tickets, right, that's going to be an important thing. She bought 8 tickets, so I'm just going to write that down. All right, and if I figure out the total cost of something, I'm going to figure out how many tickets she purchased, and I'm going to want to multiply that. We'll use high school multiplication, middle school multiplication, multiply that times the cost of each ticket. Right, that's going to equal my total cost. So we know the total cost is $104. So let's figure out that cost per ticket. Well, she has a coupon code to get $3 off each ticket. Let X be the original cost of the ticket. All right, so the normal cost of the ticket was X. But then we have a coupon, so for each ticket, we're going to get $3 off. So I'm going to subtract $3. So that was, again, X is the original cost per ticket. And then I need to subtract $3 off because I have that coupon code of $3 off. Okay, so that's the cost of one ticket, the original cost minus my $3. And then I just have to multiply that by 8 since I have 8 tickets. So that gives me my equation. 8, the number of tickets, times X minus 3, the cost per ticket, equals my total cost, $104. And which of those is the one I see? That would be 3. The third one is correct. In number 1, they switched the 3 and the X. So number 1 would be saying is that Claire only bought 3 tickets and she had an $8 coupon, which is not the case. And then in number 2, this would be saying that she took $3 off one time. So it's like she paid 8 times for the cost of the tickets, the original cost of the tickets, and then she just got $3 off total. But in this situation, Claire didn't get $3 off total, she got $3 off each ticket. So that minus 3 has to be in the parentheses. All right, this is the challenge, try it, so read it, give it a shot, and I'm going to have the answer following soon. So the correct equation is the second one. 60% off is the same thing as taking 40% of something. So we do 0.40 times X plus the price of the socks, and that gives us the total.